you haven't noticed, there is a new wonderful piece of expressionist art hanging up above this, completed above the whiteboard. Only one person worked on it, and his name is Zeke, and it's pretty baller. And he was psyched to have it hanging up, so if you see him, if you remember, feel free to mention, like, man, your art's pretty cool. Or terrible. Like, be honest with him. Kids need criticism. All right, so here we go. Don't really be mean to my kid, just for the record. Sweet. All right, looking at this, we're going to draw and try to do this. Key. Awesome. Now, as we go through this, what I would recommend, if you were able to complete this in a group or independently, and you have everything done, I would suggest you go through and grade it. Now, I'm not going to collect it for a grade, right? But if you got a 10 out of 28, probably tells you should probably study a little bit, and it's a good kind of metric to use to compare yourself against. But let's jump in. If I'm looking at this function, it's kind of a wonky function. It looks like a bunch of different pieces. What is the range asking about, just in general? And we're going to rapid fire numbers here today, okay? Everybody remember your number? Everybody's phone in there? I don't really check that often. Until I catch people texting, I try to be pretty chill with it. Cool. All right. So, rapid fire. Do you guys want like 2 minutes to discuss anything before I just start calling on random people? 2 minutes to go through everything so that when I call on you, you don't have to be embarrassed because you don't have an answer. Okay, 2 minutes from right now, we'll jump in. Chat it out. I'm not giving you time to work full problems, but just anything that you don't know how to answer if I ask a general question. Good discussion time. 2 minutes. So right off the bat, on this first problem, we are looking for the range of this function. Number 11. What's the range asking me to find? Which type of values? The y values. And number 11, that was Michaela. That was you, right? Awesome. Okay, so looking at this thing, what's the smallest y value that we ever use? 0. And it's, do I include it? So I'm asking that because it's the difference between a bracket and a parenthesis if you use that. Did anybody use set builder? Me too. I think it's much nicer. It looks nicer. It's easier to make sense of. But here we go. Two options. If you have set builder, we have the set of all y values such that every y is greater than or equal to 0, right? What's every y value on this graph also less than or equal to? What's the highest value? 13. Do we take any gaps or anything? Nope. So here it is. Boom. Here's set building notation. If you don't like set builder, that's completely okay. You might have used interval. We would have 0 because it's included all the way to 13. Okay, this was worth 2 points. Did you try it and did you get it right? Now, for my set builder, if we are going to commit to this, I will try my best to always make it really clear. You do not have to include this, but this just reads y is in the set of, and it says everything from 0 to 13. Okay, 2 points here. I am super kind with partial credit as long as you show work and try stuff. Like a 0 on a test, the only way you can ever get a 0 is you literally just get your test, look at it, and hand it back to me and don't try anything. Cool. All right, number Elijah. What's the domain asking for? Good. What's the smallest x value that I ever pick anywhere on this graph, everybody? 0. Is it included? Okay. So x is always greater than or equal to 0. And what's the last one? 8. Look at that. We have our domain now in set building notation. If you don't like set builder, it's no longer the set of y that are in an interval, but it's the set of what? X, and they're in the set of, or in the interval, if you'd rather, from 0 to 8. Just so you guys know, if you are looking at your test and you're like, yes, I got it. When I graded 6 hours, and we didn't have the weird map stuff with them, so we could actually grade it as a quiz, check really closely. If you have parentheses here, are you correct? No. If you have parentheses, you're wrong. How many points do you think I would take off out of 2 points if you have one half? 1/2 point. Not 1 point, half a point. Cool. So you still get 75% of it if that's just a little typo. Okay. Everybody, yep. If you're not cool with it, instead of me asking over and over, is everybody cool? You're just going to rudely, or not rudely, interrupt me and to say, like, expand. Agreed? Cool. All right. Uh, their average rate of change from 5 hours to 6 hours. So it looks like I'm just looking here. What is average rate of change again? It's just a slope. It is just a slope. Now, you do not have to have the exact same notation as me, but I always call it a rock. I want to find the slope between this point and this point. If I do y2 minus y1 or vice versa, what do I get for y2 minus y1? Like, what value should I plug in? What's the y values that we're at those points? So I'll even write the order pairs. I'm good with that. This is the point 5, 7, and this over here is the point 6, 7. Unintentional. Cool. So if I do y2 minus y1, 7 minus 7. Okay. Divided by what? 6, just 6, 5? 6 minus 5. Okay. I cannot control Z on this. 6 minus 5. And then let's clean this up. 7 minus 7 is 0 over 1. And it feels silly to write this. What's a better way to write 0 over 1? 0. Now, check it. Find the runner's average rate of change with the appropriate units. If you didn't include units, I would take off half a point, just so you're aware. When we talk about this, what I saw at 6 hours, a bunch of people saying there is no rate of change. But check this out. Is 1 a number? Yeah. And it represents one thing, right? I don't care what the thing is. But we also need a way to represent 0 things, or the absence of stuff. So in the same sense, is 0 also a number? There is a rate of change. It's just 0. Don't say there's no rate of change. That would imply that it's undefined. We can't talk about that one. If you got 0, just call it 0. What are my units? How do we measure y? So miles is that, right? And the time, or the x-axis, was measured in what? Hours. It wasn't miles per hour, but you're jumping ahead, Lando. That's okay. I'm going to write miles per hour. What's up? Are you sure? Yep. Okay. What could have possibly made it so that they were going 0? Yeah. Anybody here ever ran a half marathon that's 13 miles? Okay. It would take me so much longer than 8 hours, I think. I don't know if that's really true. Maybe not. You're walking a mile an hour, you can walk 8 miles in 8 hours. I could probably do that in 13 hours. Angel. What's up?
He just wrote down, we said it was constant. He just like wrote down.
Yeah, let me change your zeros. I'm sorry. But the 0 looks like 0. This one looks like 0. Try not to do that. Like, I wouldn't count you wrong for it. But you should calculate it, Angel. But I'm okay if you reasoned it out like that. Okay. They rest. They can take a nap. They can go potty. They can eat lunch. I don't care what they're doing. But they're not moving. Okay. Do you guys want a random fact just that seems weird when you hear it? Do you guys wake up and go to sleep in the same location typically? Okay. Now, velocity has a direction with it, right? So I can walk in a positive direction or a negative, and it gets more complex when we look in 3 dimensions, but there's positive or like all that stuff, right? Now, if we looked at the total distance from where we start the day and where we end the day, do you agree that in the overall change of things, if you wake up and go to bed in the same spot, your net or your displacement is 0? Like you move throughout the day, but if you just do the average between start and end, it's 0. Which means no matter how fast you walk all day long or run, it doesn't matter. What's your average velocity every day? 0. Unless you don't go home, in which case it'd be different. But cool. All right. 3 points. Did you try and did you get 0? And did you say some sort of explanation? There's a bunch of possibilities for why they stopped. Everybody cool there? All right. This one is our transformation question. I need order of operations with the understanding that I think we should just use GEMS for the record. I think GEMS works nicer than PEMDAS only because there's other groupings besides parentheses and maybe we don't always physically write them. But checking this out, if we use order of operations, I know that I'm doing squared. I can't actually square this, so I'm not going to start with my exponent though. But let's look. Number 7. If I was just trying to evaluate this expression, what's the first thing you would do according to order of operations? Are you 7, Lily? Yeah. All right. So, number 7. If I heard parentheses from the room. What's inside the parentheses here? Okay, the fact that I have x minus 1 tells me my first transformation. What should it be? 1 unit right. Now, when I graded this, and when you see a question similar to this on the test tomorrow, I make it 5 points. There are 4 transformations that we have. If you list all 4 of them, you get the 4 points. The last point comes from, do you get them in the correct order? Okay, so we did the x minus 1. We did inside the parentheses. That's awesome. Number Amy, what's next according to order of operations? Excuse me. Compress or stretch. Love it. Just to clarify the question, Amy identified correctly that the next thing in order of operations is to multiply because we're multiplying out in front. Now, this one, 2 and 3, they can switch back and forth. I see that there's a number in front and it's 1/2. Is that between 0 and 1 or is that greater than 1? It's between 0 and 1, right? So less than 1. If we do that, it's a vertical change because it's out front. And if it's less than 1, do we compress or stretch? This is a vertical compression. My graph got wider. Vertical compress. Now, there are a few ways. If you just write compress, I'm fine with it. In mine, I would say it's vertical compress by factor of, and I would accept 2 or 1/2. I can see, like, I didn't give you a point for this. I just want it to be clear. It's half as tall, so I'm compressing it down to by a factor of 2. Or 1/2, if that makes more sense for you guys. 1/2. Cool. Now, 2 and 3 are interchangeable. I've addressed the 1/2 part of it. But gosh, number Chetty, the negative out in front also does something. Love it. Reflect over x-axis. Reflect over x. These two are interchangeable. It doesn't matter whether we reflect first and then compress or compress and then reflect. They're part of the same operation. Cool. Now, last but not least, Sebastian, we have dealt with the parentheses. We've done multiplication. What's the only thing left to think about? The translation. This minus 3 has an impact on my graph. What does it do? 3 units down. And look at that. If you had these in the correct order and you had all 4 of them listed, you would have gotten 5 points for this problem. Again, people naturally want to do this one first for some reason. I think it's probably because it's, I don't know, maybe you guys don't. 6th hour definitely did. Because it's the one that's outside and stands out. If you have all 4 of these, you have 80% of your points here already. Yep, because there's 5 points on this problem. I was wrong. 4 here and 1 for the correct order. King. I would have given you a -1, but there's 5 total points, so you get most of your points for the problem still. Okay. Questions, clarification, compliments, insults? Okay, cool. The front page would have then been worth, let's see, 12 points if we'd had it, but cool. Back side of this. Number 3 is the hardest problem, I think. Okay, there was a typo. It should have been through part D. My bad. If I want to see if this sequence is arithmetic, what on earth would you suggest we do, Zed? Okay, so how do you find a common difference? Okay, love it. That's what I needed to hear. I'm going to do it different, a little bit different. We're going to get the same answer because you got 6, I think. What does difference mean? Subtract. What's 9 minus 3? What's 15 minus 9? 6. They're all 6, right? So is it arithmetic? So here's your 2 points. Yes. And what do we need for a brief explanation? Do I need to say each number is found by adding 6 to the previous? Do I need to be that wordy? What do you think I could write to be way easier? This is fine. This is sufficient. You could say the common difference is 6. I'm good with that. We have it. It is an arithmetic sequence. Okay. On the next part, all of these play into each other. So my hope is that you notice that there are letters and you went A, B, C, D. If you went A, C, B, D, you're going to struggle a little bit. Sorry about the weird order, but Word is kind of an idiot when it comes to formatting. So, cool. All right. I'm asking realistically for two things on part B. What are those two things? I need an equation for the nth term, but I also need what? The value of which term? 53. Now, I don't necessarily expect you to memorize this stuff, but I guarantee that if you look in your notes back when we did sequences, you're going to find a couple places in 1.4 where there's a big star next to your stuff. I think that I have this formula. A sub n is equal to a sub 1 plus n minus 1 times d. This hopefully looks familiar. If it doesn't, when you looked at your notes or when you look at your notes later, you will find exactly this. This is the rule to get our nth term out. Now, I do know a few things about this. N, we're just going to keep as n for right now because we're just finding the formula first. Okay, do you guys know the first term of our sequence? Okay, so we'll just go ahead and say a sub n is equal to 3 plus n minus 1. And gosh, if only we knew the value of the common difference. Oh, if you stop here, you're okay. It kind of bugs me. I would go one step further. Is there any obvious math that I could do to simplify this number, Liam? So careful. Before I do a sub 53, I just want to know, is there anything that I could do to simplify this to make it look a little nicer? There is a distribution happening here. Cool. I'm going to do this in my head just to save a little bit of space. This is 3 plus 6n minus 6. Everybody okay without me writing that? When I combine my like terms, 3 minus 6, I get 6n minus 3. This is the nicest form of this equation. We now have an nth term formula. Okay, I also ask you to find, once you have this equation, the 53rd term. Instead of n, what am I going to write? So a sub 53, and I'm going to plug it into this. Excuse me. 6 times 53 minus 3. What's 6 times 50? And 6 times 3? 18, I think. Okay, and so I had 318 minus 3. Hey, look at that. Our 53rd term of our list should be 315. Once we have this formula, we don't have to count out the next 50 terms. Waste of time, don't do it. Plug it into our nice formula that gives us the whatever term we're looking for of an arithmetic sequence. Okay, my guess is that stuff will probably be on your note card. Additionally, so will the next thing that we're about to do. Okay, on questions, interruptions, clarifications. Reminder, the Cowboys did win last week. Just throwing it out there. Cool. All right. We are asked on C to use sigma notation to write this thing as the sum. Do I ask you to find the sum right here? I literally just say write it using sigma notation, right? Now, little weird things that happen with it that I won't be crazy with yet. First of all, what does a sigma look like?
Weird.
Yeah. The weird E. Okay, here it is. Whoa, not that, because, I mean, it could be, but I'm going to make it nicer. Here it is. This is the summation. Now, if we're trying to sum up the first 50 terms, what's the first term that I would start with? Would I start with the 12th term? That's weird. What should I start with? The first. Now, decision time. Do you want me to write I equals 1, n equals 1? It doesn't really matter. I, because that's what we have. All right. I equals 1, and we're going to start at 1, and we're going to keep going and adding terms until we get to what number? The 50th. Okay. In here, the argument, the thing that we're taking the summation of. We need to make sure that whatever we plug in here, it generates exactly this sequence. Another way to word that is if we had a formula that would give us the nth term for the first, the second, the third, so on and so forth, we could plug it in here. Do we have a formula that gives us the nth term of this sequence? What is it? Hey, look at that. The argument of my summation is 6n minus 3, but here's the weird part. that, again, this I won't count you wrong for. We're using what letter to keep track of number? So instead of n, what should I write? -3. If you wrote n here, I would not count you wrong. The alternative would be to write n equals 1 to 50 and then plug it in. But we have it. This is all I was after. Did you write the summation and did you have the correct argument? Are your 2 points here? If you wanted to use n instead of I, this is all it changes. Let's just write it as n equals 1 to begin. And we have 6n minus 3. And you could use K or L, whatever letter you want. I wouldn't use O because that's super misleading, but cool. Awesome. For the last one, I overheard a group yesterday, and I'm so glad that I did, saying, let's just add up the first 50 terms. If you have a calculator, could you do 6 or 3 plus 6 plus 9, and you could do it all the way out, right? Now, to avoid that, because I don't want you to do that on the test, I bet I ask you to sum up like the first 1,000, so that if that's the route you take, you won't have time to do it. I don't want you to do it that way. It's a bad way to do it. You can, and it works, but there's better ways. Okay, if I want to add up the first 50 terms, I remember the story of Carl Gauss. Sweet. Do we have a formula for this? Yeah. Now, we can write the summation like this, or normally we write it as capital S for the sum, and we're trying to add up the first how many terms? 50 in this case. But when I'm going to write the formula just in general, and then we'll plug in 50. If you don't want to write both of them, that's fine. S sub n for an arithmetic series, which just means we're adding up an arithmetic sequence. I think it's n over 2. And then what do I multiply it by? Not 50. Not 6. Ooh, louder. A sub 1 plus something. A sub n. Okay, if we know the number of terms we need, 50 in this case, do we know the first term? And we don't have it written, but could we possibly find the 50th term in our list? Just like we did the 53rd, I think we could. Bless you. Bless you. So let's do S sub 50. What am I going to plug in for n? So n over 2 is 50 over 2. What was the first term of my sequence? Plus, it's going to take a little bit of either mental math or scratch work. Using this, can you tell me what the 50th term is? 6 times 50 is 300, and then minus 3 is 297. Cool. Now, are you guys allowed to use calculators in here? Somebody said no. Who said no? You know we can, right? Was that Lando that said it? Whoever it was, just to be really clear, like I'm not mad, we can. Cool. There's calculators back there. If you want one, I have extras. But let's do this. If you use a calculator, that's fine. I'm going to do this a little bit easier. Do you agree that this would be 50 over 2 times 300? If we cleaned it up. How do you guys do this multiplication? You divide first? Would you do 50 over 2? Do I have to do 50 over 2? Could I do 300 over 2 first? That's how I would do this. 150. And these numbers are big. 50 times 150 is big. But do you guys know what 5 times 15 is? Or can we work it out at least? Yeah. 5 times 10 is 50. Plus 5 times 5. I think this is 7,500. Okay. Here's the deal. I'm going to go to the document camera real quick. Sonny, do you have a question? Are you sure? Michael, what's Sonny's question? Because he just asked you the question, I'm pretty sure. How did we get 297, Sonny? Yep, we just used this exact formula to get it. Cool. All right. I'm not going to make you guys like type this in and stuff. If you want, if you have an answer on something tomorrow, I am more than happy to show you this. But let me open the document camera real quick. All right. So check this out. You guys are going to have to remind me of what we just did, but we're doing some math right now. Do you guys agree with that? Okay. So check it. I see there's a math button on my calculator. If I do, first I better turn it on. If I do math, here we go. I'm in the math column. If I scroll down, and I would encourage you guys to dig around in these. Does anything look like what we're trying to do? Oh, my summation. Hey, what do we want? I'm going to use x. Where did x start in our formula? This started at 1 and went to where? And what was the argument, the thing that we just took the summation of? So it would be x in this case because I changed it to x because that's the variable that I have. 6x minus 3. And we got 7,500, right? I'm going to delete that one. Delete. Hey, you can check your answers. I will help you check your answer. As long as I can see the formula that's on your sheet, I'm cool with it. Baller. Cool. All right. If I was looking at stuff that if we don't get to it in class that I would put on your note card, this is for sure one of them. This is for sure one of them. And we'll have a little bit of time to work on our note card, but we won't have the whole class. All right. This one, by hand, we are constructing a graph. And just so you guys know, this video will be posted. I can even upload the PDF of the key if you want me to do that, so you don't have to watch a video. I have no issue. How many graphs, how many different pieces does this function have? 2. Where I see people getting goofed up is trying to graph and shade and stuff because you see some inequalities here. This is not a system of inequalities. We have various particular expressions. We're not shading stuff because it's not f of x is less than or equal to, like y is less than, like this is just a system of 2, or not a system, I'm sorry, a piecewise function. If I have 2 pieces, how many tables should I have? 2. I'm going to do the top table, and we'll do this one as blue. Now, as we go through here, I want to be really clear. If you don't like the 3 columns, that's okay for now. That middle column that we do when we graph is just there for scratch work so that you can keep stuff straight. And if we have mistakes, we can find them fairly easily. Should we write the middle column here? Okay. So x and then 2x plus 1 and then the y value that it spits out. These are both lines, which make this super nice. We only need 2 points. How do I choose the points that I want to use on this thing? Number, who wins? I keep getting the same numbers over and over again. Cool. Number, Talia. How do I choose the x values that I pick for the top function? I'm going to use the boundaries. That is a perfect answer. When I say the boundaries, are there requirements for that top function? Fred, what are one of the x values that I say the top function works with? Okay, before I do anything else, it's underlined, meaning open or closed point? Closed. So this middle column, again, totally optional. All it tells me is if I do this, it's 2 times negative 2 plus 1. What's 2 times negative 2? Plus 1? Negative 3. Here's an ordered pair. Cool. Can you tell me the next point you would like me to plug in? Naomi. 0. Is it open or closed? Because it's or equal to. And if I do 2 times 0, that's 0 plus 1? 1. I have 2 points. I can connect them. All right, we're going to switch colors here. For the other function, the bottom function, and I'm just going to use BTM, we have x. I'm not going to do the middle column for this one because it looks super confusing. Is that okay with everybody? Okay, because I think that you can change a sign pretty well. Okay, for the bottom function, number Julia, what would you like me to plug in for x first? A 1. Any mark I should put next to it? Open. Because it's just greater than and not or equal to, it is open. My function is negative x. If I plug in a 1, what does it spit out? Negative 1. Any other point, Kyle, that I can choose here, as long as it's greater than 1, any number works. 2 is a natural choice. Do I have to make a note here about what it is? If it's not on the boundary, it's guaranteed to be closed. You don't even have to make it, don't pay any careful attention to it. If you plug in 2 for x in a negative x, it gives me a negative 2. All right. This one, again, I can't draw straight lines, so you will have to forgive me. Because it is my boundary. Every time I'm going to guarantee and I'm going to always pick those. And you have to pick those, especially if there's 2, but this one's here. Okay, so your graphs, I will give you graph paper and I'll make sure that you can see the lines and stuff on it. But I'm going to try my best without having a straight edge. Okay, so we got -2 to 2, so -1, -2, 1, and 2. And I'm just trying to be kind of consistent. And I go down to -3, -1, -2, -3, and I go up to 1. All right, I'm going to plot these points real quick. The first one, and I think that's the same color blue, we got -2, -3. Do you guys agree that's right there?
Yeah.
And 0, 1 is here. Okay, I want you to tell me my mistake, because people do this all the time. If I have 2 points on either side, I only connect them. Here's the first part of my function. Cool. The next one, when I switch to red, I'm going to plot the point 1, -1, so it looks like it's here and it's open. And then I'll plot 2, -2. Is this really a boundary here? No, so do I stop at it? Nope, how far do we go? Forever. There it is. Here's our graph. Piecewise functions are always like make people uncomfortable. Do they feel better now than they did before? Is that a real yes, or are you just trying to think that's the answer I want? Hit it. Because if it's not on our boundary, we don't have to worry whether it's defined. It is defined. The only places where it could possibly be undefined are the boundaries. So unless I had something that said less than 2, it's going to be closed. All right. Okay, this last problem, very last one. When we look at this, I'll tell you on the test, it's going to be nicer. I was trying to save you a little bit of having to do more problems. There's really 2 problems living here. There's one problem that says graph and solve the system, sorry. One problem that says graph and solve the system of inequalities. That's our first one. The second one says find the intersection, and that's like solving a system of equations. Okay, let's do the inequalities first. You can show as much or as little work as you need to graph, but if all I see is a graph and I ask you to explain how you got it, and you can't because all you've done is graphed it on your calculator and copied it, I will not give you points, just so you're aware. Okay, it's pretty easy to tell whether or not somebody's used a calculator because I can tell by the points that you pick. So I'm just going to jump right into graphing this. So when we graph these, remember, we always just assume like it's equal, and then we use the inequality symbols for the shading part. Okay, I'm going to be really lazy with my scale, so we have a little bit of time. Here are 5s. So I'm going to eyeball out where 1 would be here in just a minute. For the top function, if this is equals, could we solve it for y? And we could do some dividing and stuff.
Yeah.
How many of you guys are still doing that? And that's okay. I'm never going to do it that way if I get a nice equation in standard form. If y, looking at just the top equation, if y is 0 and like it's gone, what would you get for x?
3.
On the top one, if I do 2 minus 0 equals 6, I would get 3. Okay, so when x is 3, y was 0. Or when y was 0, x was 3. That tells me I get the ordered pair 3, 0. So that's about 3. Okay, when x is 0, it's like this term is gone. If it was -3y equals 6, what would you get for y?
-2.
Okay, -2. So I get the point 0, -2, which is about here. Before I draw my line, what do I have to consider?
Open or closed?
Good. Is this indicated open or closed?
Closed.
Which means solid or dashed? Solid. Okay, I'm going to draw through this. Now, I'm going to try. That was actually way better than I was expecting. Okay, when we go through, anybody still struggling with the shading part of these? Okay, so I'm going to try to explain this a little bit different. I'm not saying anything new. I'm just wording it differently. Do you guys agree that this singular line right here cuts the plane into 2 parts? There's this entire part and this entire part.
Yeah.
Okay, if I want to think out in my head which half is shaded right now, is there a point not on this line that we could test? 0, 0 would work. And Angel, you're right, 100 something would also work. But if I get the chance to use 0, 0, 100% of the time I'm going to. So if I were to test 0, 0, and I'm going to use all the same color so that it looks like yours, uh, this is less than or equal to 6. Let's just test. 0 minus 0 is less than 6. Is that true or false? Is the region with 0, 0 on the left or the right side? So in my head, I've already shaded the left side. Okay. For this one, like all of this up here is shaded right now, but I can't undo it easily. For this one, I'm going to graph it the same way. If x is 0 and this were an equal, what would y have to be?
2.
So we just got when x is 0, y is 2. So we'll plot that point. And that looks 0, 2, roughly. I will give you a better scale, just so you know. What if y is 0? What would x have been?
4.
Okay. So when y is 0, x is 4, which is about here. And close-ish. Solid or dashed?
Solid.
Solid. So I'm going to try my best to connect these, and this angle feels odd. Nope, we'll try again. Ugh. Close. Now, this is going to be a challenge, but if you struggle with shading, don't erase yours. But do you agree that this line also cuts my entire plane into 2 pieces?
Yes.
Okay, so before we had everything up here, and I'll put that other line back in just a moment, what test point could we possibly pick for this one? 0, 0. So let's try that. If I label my equation, or inequality, because we should, 0 plus 0 is greater than or equal to 4. True or false? False. Which means, do I shade the region with 0, 0 or the other side? So it's everything up here now. If 0, 0 is false, which it was, I would shade the other half of the plane. Now, if you don't like shading it as you go, we can make sense. For this first one, everybody seemed to agree that it was everything up here. If I look at the whole graph, it means there's a region like right in here that we could do, right? I'm not going to do it like that. I'm just going to put a singular x in that region and an x in this region. Everything above or up here just got an x. That's where I would have shaded. For this one, 0, 0 was false, so we shaded up here, right? Do you guys agree that there's 2 regions up here when we consider the other line?
Yes.
They both get an x. How many inequalities did we have? We had 2. Is there a region on the board that you guys can see very clearly has been shaded twice? Is it this triangular looking shape? Okay, I'm going to make a mistake, I think. I want you guys to tell me my mistake. I tried to stop at the axis. Is the axis one of my boundaries or constraints is what another common word? Don't stop at it unless you had to draw it specifically from one of these. There's our shaded region. It's wonderful and beautiful. Okay, this is part 1. On the test tomorrow, there will be 2 separate questions where I say do an inequality. Or if everybody's cool with it, because it saves time and the number of problems you have, we can do one exactly like this. And I can just put 2 questions on the same thing. Okay, that was part 1. That is sketch the system of inequalities. We got it. Then they asked me to find the intersection. And by they, I ask you, rather, to find the intersection. Okay. Anybody confident what that point where these 2 meet is? So are you confident because you did the work or because you're looking at it? Or do you have a different question? Okay, deal. Could we all agree that, not a clue. I know it's less than 5 right now in the x direction, and it's kind of small in the y direction. If I had a really good graph, you might be a little bit closer, like maybe it's between 3 and 4 and less than 1, but we'll get there. Can you guys tell me, especially since we've labeled, which equations I need to set, like, to solve?
Y.
So don't give me y equals because I don't have any y equals written here. This is where this line meets this line. Everybody agree with that statement? Now, the inequalities is just for the shading part. If I wanted to, could I rewrite this thing as 2x minus 3y equals 6?
Yeah.
And x plus 2y equals 4. Notice, we're done with the inequality part. I just want to find out when these 2 equations, notice equation, equal, equation, happens. We have a system here. There are 2 options from which we can choose. What's one of them? Hit it, Zed. We could use substitution. It'll always work. Can you tell me another one, Mark? Substitute or elimination. Do I really care which one you use? No. Not at all. I would use substitution here, personally. You can use elimination. That's fine. I would use substitution. I'm going to solve one of these 2 equations for one of the variables. Which equation? Yep, I'm going to solve it for x as for Scovia. Is it the top equation or the bottom equation?
Bottom.
I'm going to solve the bottom. Now, I always draw this the same way. I think it's reasonable that we could all solve this equation for x equals something right now. X equals 4 minus 2y. Okay, what am I going to do with this value of x? Where? To the other equation. So here I have this whole equation. I know what x is equal to, kind of. I don't have a number yet, but let's do that. Instead of x, what did we just say we could use instead? 4 minus 2y. Cool. So 2x minus 3y still equal to 6. Can we solve this for y? I think so. I'm going to go kind of fast here. 2 times 4 is 8. So I have 8 minus 4y. But before I write 8 minus 4y, can you guys tell me what minus 4y minus 3y is going to be? 8 minus 7y equals 6 still. Cool. Help me solve for y. What's next? Subtract 8. So negative 7y equals now negative 2. And y then is equal to what? So it would be negative 2 over negative 7, 2/7. Because we divide by the negative. Cool. Well, that's half the battle. Would you believe it if I said that this point was 2/7, like less than 1? It looks pretty low. Why? If we had an inequality, absolutely. But because we don't, there's nothing, like, I'll flip the equal sign. Cool. Are we done? Why not? Plug it in. Hey, I have a way right here that says if I know what y is, I can get x. I'm going to save a little bit of time. I hope that everybody in here could handle the fraction, but I'm not your, like, middle school math teacher, or I don't know when you guys learn fractions. Anybody remember? 6th grade, somewhere in there is probably where you start doing this stuff. I cannot say the number 6 anymore. Okay, I'm going to cheat through this. 4 minus 2y, and it's 4 minus 2 times 2/7, right? So here we go. 4 minus 2 times, what was that y value? 2/7. All right, I'm never going to write a decimal and a fraction. That's terrible. But I'm going to math frac it up. I hit the math button, I frac it, and here we go. Oh, it's 24 over 7. X, we just found, was 24 over 7. That is like 3 point something. Does this look believable for 3 point something in the x direction? Last thing, last points. How should I write my answer here? Okay, I will make sure that we don't get ugly fractions tomorrow because that's not really the focus that I'm after. With a calculator, everybody should be able to do it. Without a calculator, I hope you can do it. If you still have no idea how to deal with fractions, please come see me. We can do a bunch of fractions. Cool. I talked at length about all of those problems just now, and it took 43 minutes to be as detailed as possible.
Thank you, Charlotte.
I got you. With that in mind, what I always kind of aim for is I think that for the most part, if a test takes me 5 minutes, I essentially multiply by 8 to get to your guys' time. So 40 minutes, probably appropriate. Cool. As we go through, we did not have a ton of time to look at the note card thing. Here is what I want you guys to do. First and foremost, when you make a note card, it's always weird because, not when you make it, but everybody needs something different. Like, we're not all going to use the same note card. That wouldn't make sense. We're all different people. What we didn't have time to do, because we just reviewed this, is to look at what a note card would look like. As we go through, I'm going to move this, I'm going to move this, and I'm going to scroll down just so we can see it. Okay, this is what me, and it's just not going to be on the video, so I'm just going to put it here. Can you guys see up here still? Okay, I'm going to pass out note cards to you guys. You are all in Algebra 2. So here's the deal. You can put whatever you want on your note card as long as it's written by your hand. Okay, you cannot use somebody else's note card. You cannot type them. As we're going through, here's what I would suggest. This is yesterday in the 6th hour. we did, like, this was a quiz for them. What I did was I opened up the textbook, and if you guys have a text, or if you don't have it in front of you, at least write this down. At the end of each chapter, there's a very, like, structured review little area. So here I am, and I'm going, I think it's page 54, if I recall. Okay, on page 54, you will see what looks like topic 1, topic review. All that I did yesterday was 6th hour. And if we need to do on the next quiz, we can. But all that I did was 6th hour was using our notes in this book. I went through and I just identified with their help what they considered to be the most important or the stuff they struggled with. On this page, it'll hit it. Okay, in lesson 1.1, we looked at the domain. And then we looked at some other key characteristics, increasing, decreasing. We'll hit all those again. I'll tell you right now, the only question about features it'll ask tomorrow is what is the domain of something? Domain and range. Those are the features that I care about right now. Okay, every single section has examples and a brief summary of what happened. As we went through 6th hour, we looked at chapter 1 and said, or section 1, and they said, yep, we looked at domain, that was hard. We looked at range, that was hard, and we looked at the average rate of change. This is what me and 6th hour agreed is like what the bare minimum of what they should have about chapter 1. If you remember all this, do you have to write it down? No, absolutely not. I do not require the note cards. If you choose not to do one, that's your choice. But I guarantee that we'll be able to see that you did not make a note card when it comes time looking at your grades. In section 2, it was all the transformations. This is my single summary. I'm going to hook you guys up. I will not put B in tomorrow. There will not be any horizontal changes. Cool. Like, we might move left and right, but we won't horizontally stretch or compress. Written in your own hand. I'll probably make you turn them in. Tomorrow's our test. I'm going to put some note cards on the back desk. You can use front and back, side, anything that you want to write is fair game. All right. If anybody wants help with a note card or you want to check it out, you can come see me at lunch. Or if you do it tonight and want to know if it looks all right, tomorrow morning swing by before school and I'll take a look at it. There's no study hall today. It's going to be a meeting. Later, Raiders.